Forget what you learned in biology class. Forget the physics textbooks, that rulebook for reality you've been handed your entire life. Science just ripped it to shreds. We've all been taught two fundamental truths, that our biology is our destiny, and that the world runs on scarcity. It turns out both are lies. In the next few minutes, we're going to look at recent breakthroughs in genetics and energy that are so profound, they prove the world you think you live in is already gone. This isn't science fiction, and it's not a forecast for some distant future. This is a briefing on the world as it exists right now, in the final months of 2025. For generations, we've built our lives around two unshakable pillars, the biological code we inherit and the physical limits of the world we inhabit. We believed our DNA was a fixed blueprint, a life sentence of predispositions we couldn't escape, and we believed our civilization was built on a foundation of scarcity, a constant, desperate scramble for finite resources and energy. Those two pillars of our reality have just been pulverized, not by a new philosophy, but by cold, hard, repeatable science. The breakthroughs are so new that the ink on the research papers is barely dry. They show that our biological destiny isn't fixed, but programmable. And they show that our future isn't one of limits, but of mind-bending abundance. We're going to look at the two lies your textbooks taught you and expose the scientific proof that's making them obsolete. First up, the lie of our biology. Section 1. The genetics revolution rewriting the code of life. For all of human history, our genetic code has been the ultimate tyrant, a microscopic dictator ruling from inside every one of our cells. It decided if you have blue eyes or brown, if you'd be tall or short, and in the cruelest twists of fate, if you would be condemned to battle an inherited disease. Conditions like sickle cell anemia, cystic fibrosis, and Huntington's disease weren't just illnesses, they were inescapable destinies, passed down like a cursed heirloom. We accepted this as a fundamental rule. You play the hand you're dealt. Well, that rule has just been broken. The first crack in the dam was a technology you've probably heard of, CRISPR. It was revolutionary, often described as a pair of molecular scissors. For the first time, scientists had a tool that could find a specific, faulty gene within the 3 billion letter library of our DNA and simply snip it out. The potential was staggering. But even CRISPR was, by today's standards, a little blunt. Cutting DNA is powerful, but it relies on the cell's own messy and sometimes unpredictable repair mechanisms to finish the job. It was like using scissors to edit a sacred text, effective, but not always elegant. But the pace of this revolution is just breathtaking. What was cutting edge a few years ago is now being surpassed by technologies so precise, they were pure fantasy a decade ago. Forget scissors. Today, scientists are using a word processor for our genes. Enter the world of base and prime editing. These are second and third generation CRISPR technologies that have come of age in just the last couple of years, and they are changing everything. Base editing, developed by brilliant minds at places like the Broad Institute of MIT and Harvard, doesn't cut the DNA. Instead, it chemically converts one single genetic letter into another. It's like finding a single typo in a 1,000-page book and correcting it with a pen, leaving the rest of the text perfectly intact. As of 2025, a base editing treatment for a severe form of glycogen storage disease is already in phase 1-2 trials, delivered by lipid nanoparticles that home in on the liver. Then there's prime editing, a technology so advanced it feels like it was teleported from the future. If CRISPR was scissors and base editing was a pen, prime editing is the find and replace function. It doesn't just cut or change a letter. It can rewrite small sections of DNA, correcting complex mutations without making a dangerous double-strand break, which dramatically increases its safety. This isn't just a lab curiosity. In May of 2025, Prime Medicine announced the first ever positive clinical data showing prime editing was safe and effective in a human patient, used to treat a rare immune disorder called chronic granulomatous disease. Think about that. Not just tested, but working in a person. This has all culminated in what might be one of the most significant medical stories of our lifetime. In 2025, a team of scientists and physicians at the Innovative Genomics Institute and Children's Hospital of Philadelphia did something unprecedented. They created a personalized, in vivo CRISPR therapy for an infant with a rare and severe genetic disorder called CPS1 deficiency. They developed, got FDA approval for, and delivered this custom-built gene editor in just 6 months. The treatment was given through a simple 4 infusion, and doctors were able to give the infant multiple doses to ensure enough cells were corrected. A child, once condemned by a genetic typo, now has a future. This isn't just a treatment, it's a new paradigm for medicine. The floodgates are open. The first CRISPR-based medicine, Casgevy, is now approved in the US, UK, EU, and elsewhere for treating sickle cell disease and beta thalassemia, with patients actively being treated. And as of early 2025, around 250 clinical trials are underway for various gene editing therapies, targeting everything from cancers and HIV to autoimmune diseases and inherited blindness. So what does this mean for our reality? It means the biological rulebook we've lived by for 200,000 years is becoming obsolete. The idea that our genes are a fixed destiny is being disproven. Our DNA is no longer a static blueprint. It is becoming a programmable, editable code. We are moving from simply reading the book of life to actively writing the next chapter. And if rewriting our own biology seems impossible, what science has just unlocked in the world of energy is about to make you question the very limits of human civilization itself. Section 2. The Energy Revolution, the End of Scarcity. Every great rise and fall of civilization has been tethered to one cold, hard fact: energy is finite. Our world has always run on scarcity. From the first fire built to ward off the cold to the globe-spanning oil pipelines that dictate modern geopolitics, the story of humanity has been a story of struggling for energy. We've been told this is an iron law of existence, that our growth, our ambition, and our survival depend on a precarious balance of consumption. That entire worldview, the one built on scarcity, is starting to crumble. For nearly a century, there has been a holy grail in physics, a power source so clean, so safe, and so abundant it could power our civilization for millions of years using fuel found in seawater. It's the process that powers the stars themselves, nuclear fusion. Unlike fission, which splits heavy, unstable atoms and creates long-lived radioactive waste, fusion joins two light atoms, usually heavy hydrogen, into a harmless helium atom. In that process, a tiny bit of mass is converted into a colossal amount of energy. It's literally bottling a star on Earth. For decades, this dream has been a running joke, always 30 years away. It required creating conditions hotter than the core of the sun and containing that superheated plasma so it wouldn't melt everything it touched. To solve this, humanity embarked on two of the most ambitious science projects in history. One is ITER, the massive international project being built in France. Backed by 33 nations, it's a giant magnetic cage called a tokamak, designed to prove fusion can work at a massive scale. But projects of this size are slow. As of 2025, while the reactor core is being assembled, the timeline has been pushed back, with full-power experiments now slated for the mid to late 2030s. For years, ITER's methodical pace kept the dream of fusion firmly in the future column. But while the world was watching ITER, a different approach was quietly making history. At Lawrence Livermore National Laboratory in California sits the National Ignition Facility, or NIF. NIF doesn't use magnets. Instead, it uses the world's most powerful laser system, 192 beams, to blast a tiny capsule of hydrogen fuel smaller than a peppercorn. The goal is to create such immense pressure and heat, so fast, that the fuel fuses in an instant. Then, on December 5, 2022, they did it. For the first time in history, scientists achieved ignition, a net energy gain from a fusion reaction. But science demands repeatability. Was it a fluke? The answer came in a series of thunderous breakthroughs. They didn't just repeat it, they shattered the record, again and again. On July 30th, 2023, they did it again with a higher energy yield. On February 12th, 2024, they more than doubled the input energy. And then came the shot heard round the world. On April 7th, 2025, NIF's lasers fired 2.08 megajoules of energy at the target. Moments later, detectors measured an output of 8.6 megajoules. That's a gain of over 400%. The psychological barrier was broken. Ignition wasn't a miracle, it was becoming a reliable, repeatable process. The confirmation from NIF has lit a fire under the entire field. Private investment has flooded in, climbing past $10 billion globally. A new generation of nimble, aggressive private companies is now in a full-blown race to commercialize fusion. Companies like Commonwealth Fusion Systems, an MIT spin-off, are using new high-temperature superconducting magnets to build smaller, more powerful tokamaks. They're not talking about 2050. They aim to get their pilot plant supplying electricity to the grid in the early 2030s. This is no longer just a science experiment. The lie is that we are a species doomed to fight over scraps of carbon. The truth is we are on the verge of tapping into an energy source that is clean, virtually limitless, and powered by the same process that fuels the entire universe. What does a future of near-limitless clean energy look like? It's not just about keeping the lights on. It's about desalinating ocean water to end water scarcity. It's about powering systems to pull carbon from the atmosphere, potentially reversing climate change. It's about cheap, abundant energy to lift billions out of poverty and to fuel humanity's expansion into the solar system. This is the dawn of the end of scarcity as the organizing principle of our world. Conclusion synthesis. We started with a bold claim that your reality is a lie. Not as a philosophical trick, but as a tangible, scientific fact. The rulebook you were given is being invalidated before our eyes. We've seen the proof in two of the most fundamental areas of our existence. In the microscopic world of our own cells, the tyranny of the genetic code is being overthrown. The lie of biological determinism is being shattered by technologies like CRISPR, base, and prime editing, which have turned our DNA from a fixed blueprint into a programmable script. The first patients are being cured, the first personalized medicines are being delivered, and the very definition of incurable is being erased. Then, we zoomed out to the scale of our civilization and confronted the lie of scarcity. The dream of nuclear fusion is no longer distant. The repeated, record-shattering successes at the National Ignition Facility have proven that net energy gain is real and repeatable. A multi-billion-dollar private race is now on to put this limitless, clean energy on the grid within the next decade. The assumption that our future must be one of limits is being replaced by the dawn of an age of abundance. These are not isolated events. They are connected threads in a bigger story, the story of humanity breaking its chains. The chains of our genetic inheritance, the chains of our planet's finite resources, the very limitations we once thought were fundamental laws of nature are turning out to be solvable technical problems. The future isn't a place we are heading toward, but a reality we are actively building, at a speed we've never seen before. The world of tomorrow won't be a slightly more advanced version of today. It will be operating on a completely different set of rules. The real challenge now isn't just a technical one. It's a psychological one. Can we, as individuals and as a species, adapt our thinking to a reality where our biological and physical constraints are no longer absolute? The old world, defined by the rules you learned in school, is fading. We are living in the first moments of a new one, and we all have a hand in writing what comes next. Call to action. We've looked at two revolutions that are reshaping our world. Which of these breakthroughs, the power to rewrite our DNA or the power to harness limitless energy, do you think will have the biggest impact first? Let us know your thoughts in the comments below. And if this glimpse into our new reality has opened your mind, be sure to hit that subscribe button and ring the bell. We're dedicated to bringing you the facts about the future as it happens, not as it's imagined. Thanks for watching.